Okay, so I want to do just one more in this series where basically we're using the first derivative and the second derivative to find the maximum and minimums and points of inflection. And so we did a started off first video did a quadratic equation, and then we did a cubic equation, and so now I just want to do something that's kind of funky, that you just sort of go, if I just if you didn't know any calculus and I just said, you know, find this point without a graphing calculator and find this point without a graphing calculator, I don't even know how you begin. But if you're going to do calculus, it's really, really, really simple. So this is a chain rule problem. So if you're in chapter 4, you should know chain rule already. So basically it's the derivative of the inside times the derivative of the outside. Well, derivative of sine x is going to be cosine x. Derivative of x over 2 is going to be 1 over 2. And then the derivative of e to the anything is e to that same thing. So I've got e to the sine x plus x over 2. And you may very well ask, how is this simpler? How in the world is this simpler? The red doesn't look any simple. The red looks more complicated to me than the pink, but it's not, because the thing that we have to remember about e is that e, basically this part here, e to this whatever, can't equal 0. This can never equal 0. So the only part of it that can equal 0 is cosine x plus 1/2. And so if I have, so basically what I've got is I've got cosine x equals 1/2, and that's going to give us, equals negative 1/2. And that's going to give us our zeros right there. So let's turn off some of this junk here. So the blue lines give us our zeros. And you guys should know, where does cosine x equal negative 1/2? You guys should be able to answer that. Should be 2 pi over 3, and it should also be 4 pi over 3. So let's do x equals, and let's do so 2 pi, 3 pi, 4 pi. And there you go. So this function that we started with, we took the derivative of it. It looked really complicated, but since this part will never equal 0, we only had to focus on this part. This part equals 0, where cosine x equals negative 1/2. And if you know your unit circle, which I highly encourage you to do, you know that that equals 0 at x equals 2 pi over 3 and 4 pi over 3. And so then I can plug them back in. Let's take that. Go down here and replace those x's with 2 pi over 3. And so we should get 2 pi over 3. Let's just do that. Let's take this, copy it, change those to 4s. Let's turn everything off except for our original function. Well, we can leave that on. Let's take it off. Okay. So what I'm saying is that this point there should be 4.1879, which is right there, 4.1879, comma 341566, 341566, and then then this one right there should be, well, the y coordinate should be 677489, 677489, and should be 20944, 20944. So that's my last sort of video on how you can use derivatives to find the maximum and minimum of a function, and that's something we're going to use in some practical applications later on in Chapter 4.